Okay, so let's go over this do now. So it says a particle is traveling along the x-axis such as velocity given by v of t equals this equation. So the position of the particle is x equals 1, t equals 3. Determine the position, velocity, and acceleration at time t equals 4 and answer the analysis questions below. Use the calculator, run to the nearest thousand. So first thing I'm going to do is I'm given v of t. So for me, I write v of t here, and I know that I also have x of t, which is position, and I have acceleration, so a of t, acceleration. And I know every single time I go down, so this is going to be the derivative. So every time I go down, so when I go down from position to velocity, it's derivative. So this is the derivative. Whenever I go up, then it's an integral. So this is just how I keep it straight and how I think about it. So first thing is I know I'm given the velocity. So I know that I am starting right here. So I'm just going to circle that so I know where I'm starting. And it says determine the position, velocity, acceleration. So position here. I know for position, I'm going up. So if I'm going up, I'm taking the integral. So in order to do the position, what it's going to be, so I'm going to write it over here. I'm going to have x of 4 equals, and remember, to find the position of the particle, we say the original position plus the integral from the original to the final of v of t. So my original, the first thing I have is this x equals 1. So I'm going to say x of 1 plus, sorry, I'm going below here, the integral from where I start, which is at 1, to where I end, which is 4. So from 1 to 4 of v of t. Because this is saying the original position plus the amount of change that occurred. So the original plus the amount of change is going to give the final. And next, I'm just plugging that into the calculator. Hang on, sorry, I made a mistake here. It's the position's 1 when time equals 3. So this should look like the 3, and that should be a 3 there. And when I do this, I should get negative 8.513. So I'm just plugging 1 plus this integral of the v of t equation into my calculator. For the next one, so velocity. So velocity is the equation that I'm given. So when it's the equation that I'm given, all I'm doing is I'm taking 4 and I'm just plugging it in for t, and I'm just finding v of 4. So all I'm doing is wherever I see a t in this equation, I plug in 4, so it'll be 4 to the 0.6 minus 2 times 4 plus 4 cos 4. And when I plug that into the calculator, I'll get negative 9.528. And for the last one, I have acceleration. So here, for acceleration, we see that acceleration is below velocity, so I'm taking the derivative, because it's the rate velocity is changing. So I'm saying a of 4, and what I'm plugging into my calculator is I'm using that math 8 for that d dx. So I'm taking the derivative of the velocity equation, and I'm evaluating that when t equals 4. So I'm just using math 8, plugging this in, and I'm saying when t equals 4. And when I do that, I'll get 1.043. So first, when it comes to these follow-up questions, the first thing it says the particle is moving to the, so we have to choose right or left. And remember, when we see for what direction the particle's moving, that's based on velocity. So I look at my velocity, and I see it's -9, and so the particle then is moving to the left. So I'm just going to L for left because velocity, so v of t, is going to be less than 0. This one, the velocity of the particle for this, so I think this is asking for increasing, decreasing. And I look at this, I have a negative velocity, a positive acceleration. So my velocity is decreasing. So decreasing, sorry, this is very hard to see. So the velocity is going to be decrease because velocity and acceleration have different signs. So v of t and a of t have different signs. So I'm going to just say diff sign. So the speed of the particle, so velocity is decreasing, so the speed of the particle is also decreasing, and it's for the same reason. Velocity and acceleration have different sides. So this is asking particles moving either towards or away. So for this one, what I'm doing is, again, I'm going to make my number line of like what we did yesterday. So I have, here's my number line, and here's the origin, 0. I know that right now the particle is at -8, which is over here. So this is here, -8. And this is at time equal to 4. And I know velocity is negative. So because velocity is negative, it's moving in that direction. So here, so velocity is negative, so it moves left. So it's moving away from the origin. And we know this because position and velocity have the same sign. So x of t and v of t have the same sign. All right. So take a minute, read through this motion reference sheet on your own, and then go on to the next video.